right, this is lesson 1.6, and we're going to be talking about writing and solving equations and inequalities with absolute values in them. Before we do that, we need to look at the definition of an absolute value. The absolute value of a real number, x, written, absolute value of x, is the distance from 0 on the number line. So if we think about the number 4, the distance from 4 to 0 on the number line would be 4 units. The number -4, the distance from that to the 0 on the number line would also be 4. Keep in mind, it's like when we're measuring something, we take out a tape measure, and that value that we measure will always be positive. So absolute values will always be positive. When we look at the absolute value of x equals 5, we have to think about what could x equal? Well, the numbers that would be 5 units away from 0 would be either 5 or x could equal a -5. So from 5 to 0, it's 1, 2, 3, 4, 5 units. And from -5 to 0, it's 1, 2, 3, 4, 5 units also. So when we're solving absolute value equations, there will typically be two answers. So for this first problem, it says, what is the solution of the absolute value of 2x minus 1 equals 5? Graph the solution. So, like we said before, this value inside of the absolute value bars could either equal 5, or this value here could equal -5. So when I see the two lines used for absolute value, I think write two equations. So you take what's inside, and to find out what x would be, you set that equal to 5 and to -5, and then we solve both of those. So 2x equals 6, x would equal 3. 2x equals -4, divide by 2, x would equal -2. Now let me just show you how that works. If we substitute those values back in, if we substitute in the 3, you would have the absolute value of 6 minus 1. Is that equal to 5? Sure it is, because the absolute value of 5 does equal 5. It's a true statement, so that works. When we plug in -2, we would have the absolute value of -4 minus 1, and then that would be the absolute value of 5. Does that equal 5? Yes, it does. So both -2 and 3 are solutions. When we're solving absolute value, the absolute value part is kind of like when you're solving for a variable, where you want to isolate that first before you set up your new equations. So what you'll want to do is first we'll add 1 here. And then we'll divide both sides by 3. So you have the absolute value of x plus 2 is equal to 3. So now we're down at the point where we know that the absolute value, whatever this value is in here, has to either equal 3 or it has to equal -3. So we'll write our new equation. So whatever is in the absolute value, you write it just like you see it in there. And then you set it equal to the positive of the right side and to the negative, or the opposite of the right side, and solve both of those. So those should be your answer. And you can substitute those back in just to make sure that you're correct. Now, in a problem like this, where you have the absolute value of something is equal to an expression on the right side, it's very similar, but when you do the negative, you need to put parentheses around the right side. So you write, let me just erase that a minute. You write 3x plus 2 equals 3x plus 2 equals, and then 3x plus 2 will equal 4x plus 5. Or 3x plus 2 would equal the opposite of 4x plus 5. And you need parentheses because it has to be the opposite of the whole thing. So you'll want to distribute that through. And then you can solve it for x. And we need to get our X's letters on the left. Doesn't have to be that way, but it's usually kind of handy. And divide. So X equals a -1. And the other solution will be, let's see here. So we have -1x equals 3. So x would be a -3. So those should be your answers for that one. So just in summary, we have 3 little examples here. If you were going to solve the absolute value of -6x is equal to 24, you would just have to make 2 different equations. So you write -6x, -6x, set it equal to the positive of the other side, set it equal to the negative of the other side. And we won't solve those now, but I just want to make sure that you know how to set that up and then so that you can solve. On this one, you would first have to isolate the absolute value, get rid of everything else on that side. So we're going to bring 4 to the other side. So that gives you the absolute value of 2x plus 8 is equal to 16. From there, we can write the 2 equations. Whatever is inside of the parentheses, we write that down twice. First one you set equal to positive 16. Second one you set equal to -16. And then lastly, where we have an expression on the right side, you write what's inside the absolute value twice. Once you set it equal to the positive of what's on the right side, the next time you set it equal to the negative of what's on the right side, and you solve it. Okay, so that is those are absolute value or equality problems. Now we're going to be looking at absolute value inequalities as well. So again, with an absolute value equality, if the absolute value of x is equal to 3, we said that x could equal 3 or x could equal -3. So when you graph that, if this is 0, your solutions would be 3 or -3. You have 2 solutions, here and here. When it's an inequality, that's a little bit different. So if we're saying that the absolute value of x is less than 3, it's easier to explain that if we look at a graph. So when I'm just going to change this to less than or equal to. So in other words, x could equal 3. It could equal 2.9. It could equal 2. It could equal anything in here. It could equal 0. It could equal -1. It could equal -2. It could equal -3, but we're going to stop right there. Let's just look at -4. If you put the absolute value of -4 in, what does that equal? Well, that equals a +4, and that is not less than or equal to 3. So anything that's less than -3 won't work, because that you take the absolute value, so it works just like the positive number. So anything that won't work in the positive side is not going to work in the negative side. So when we do less than, when we do an absolute value, I kind of have changed the name of it. I call it less than with a D at the end. So kind of like in the word sandwich, and absolute value less than graphs kind of look like a sandwich where you have something on each end and all this stuff in the middle. So let's look at a greater, absolute value greater than. So if we make our little graph or number line, so the absolute value of x is greater than 3, and I'll change that to equal to also. If it was just greater, it would be an open circle at 3, but we're going to also include equal to for this problem. So if it's greater than 3, it would be 3, 4, 5, off into infinity. Anything bigger than 3 is greater than 3. Now, if you take the absolute value of -3, that equals 3, so that works too. And if you take the absolute value of -4, that's +4, that's greater than 3. So anything on this side works because you take the absolute value of all of these numbers. So whatever works in the positive world works in the negative world. So the solution here would be that x is greater than or equal to 3 or x is less than or equal to negative 3. So I've changed the name of greater to be great or. So when you see a greater than, you think great or. The arrow will go two directions, left or right. So using that, we can solve our absolute value inequality problems. So you have the absolute value of 2x plus 4 is greater than or equal to 6. So that's an or. So again, kind of like before, we write what's inside the absolute value. So whatever this value is going to be greater than or equal to 6. Or, remember, we have to look at the other direction of the number line. It's less than or equal to negative 6. So when you write absolute value inequality, the strategy is to write the first one just the way you see it here, without the absolute value signs. And the second time through, switch the arrow and switch the sign. So change the arrow, change the sign. And then you can solve those. Divide by 2, x is greater than or equal to 1. And divide by 2, x is less than or equal to negative 5. So if we look at that on a number line, we have 1 right here, negative 5 over here. So x is greater than or equal to 1. That says anything on this direction would work. And x is less than or equal to negative 1. Anything in this direction would work. The next one, we'll just quickly set that up. We're not going to solve it through all the way. And it's a greater, so we write greater than 15. Second time, we switch the arrow, switch the sign. And then you can solve that. So negative 15 is over here. Let's look at this next one. Here we have a less than. The absolute value of 2x plus 2 minus 5 is less than 15. So first of all, just like before, like I told you, we need to isolate the absolute value sign. So we will first add 5 to both sides. And it's a less than, so we know when we graph it, it will look like a sandwich. Now there are two ways to do less than's. The first way is like what I showed you before, where we write 2x plus 2, repeat that, write 2x plus 2. First time, you write it just the way you see it above, so it's less than 20. The second time, switch the arrow, switch the sign. And now we can solve. Divide by 2, so x is less than 9. So that's one part of the solution. So we have 2x is greater than negative 22. Divide by 2. X is greater than negative 11. So when we graph that, negative 11 is here. 9 could be about up here. So x is less than 9. So that's an open circle, and it's going to go that direction. X is greater than negative 11, open circle, and it will go that direction. So in other words, any value within these two numbers will work if you plug it in. For example, 0 is right in the middle. If you plug 0 in here, you'd have 2 times 0, 0 plus 2. Absolute value of 2 is 2, minus 5. That gives you negative 3, and that's less than 15, so that works. Now the other way that I said you could do this is when you're doing a less than, you know you're going to end up with like a sandwich type graph. So you can write 2x plus 2, and instead of writing them as two separate problems, you can say it's less than 20, which is what we did on the other side there, and it's greater than negative 20. So it's sandwiched in between those. And then when you solve, you have negative 22 is less than 2x, which is less than 18. So negative 11 is less than x, which is less than 9. There again, that shows you your range right here. So both ways here will work. Now there are some special cases to watch for. Like if you see something like this, the absolute value of x is equal to -5, think about what you could substitute in. Let's say you substitute in 5. Absolute value of 5, well that's 5. That I said less than. That, sorry, I didn't mean that. Absolute value of x equals -5. So if we look at the absolute value of 5, does that equal -5? No, that doesn't work. If you put -5 in, what's the absolute value of -5? Well, that's 5. That doesn't work. Like we said in the very beginning, absolute value, when you take the absolute value of something, it's a distance, so that is positive. It's never going to equal a negative. So anytime you see that right from the beginning, you would say no solution. The next one is similar. Absolute value is positive, so it's never going to be less than a negative number. Now, in this next problem, if you take the absolute value of any number, it's positive. Positives are all greater than -5, so this would be infinitely many solutions. There you go. So watch for those special cases to pop up. I'm just going to hop back here real quick. For example, if you see 2x minus h is equal to a -3, your first response should say, we're saying the absolute value of something is equal to a negative. Can't happen. That's no solution. So watch for that. And real quick, I want to talk about a tolerance problem with you. So here's a problem where we would see absolute value used in real life. This problem says the radius of the gears produced at a factory must be at 6 inches in length with a tolerance of 1/10 of an inch. The gears with radius beyond the tolerated lengths will be thrown away. Which of the following inequalities can be used to assess which gears are eligible? So those gears need to have a radius of 6 inches. So the way that we do problems like this is we're looking to see how far away the actual gear that we're testing is from what we want it to be. So the formula is you take the actual length of the object you're looking at, and we subtract the desired length, what we want it to be. And we take the absolute value because we always want that to be a positive number. And in this case, it says it has to be within 1/10 of an inch. So it either has to be less than 1/10 or equal to 1/10 of an inch. So for example, let's say that you were looking at one and it was 6.2 inches when you measured it. So if you pop that in the formula to see if it would work, 6.2 minus what we want it to be, which is 6, that gives you 0.2 or 2/10, which is 2/10. And that is greater, that is not less than 0.1, it's greater than. So that one would not work. You would have to throw that one away. Let's say that there was one that was 5.9 and you were testing that. 5.9 minus what we actually want it to be, 6. Well, that would be a -1/10. And if you take the absolute value of that, that's 1/10. And that is equal to 1/10, so that one would work. And that's it for this lesson today. Thanks for listening.